Hello, students. Got a couple questions come in through email here in section 13.2. First one was about question 6. There's an A and a B, so why don't I do A and then I'll leave B for you, maybe if you want to do it the same way. So as you're looking here, you're trying to find the area of the figures. And the area of the figures that we're looking at here is probably done with, well, there's multiple ways to do it, but probably the easiest way to go about doing it is to not worry about weird too weird of shapes and just build yourself a big rectangle that goes completely around the shape, and then try to find kind of what you might consider simpler shapes as you're going about and doing this part of it. So that would be my recommendation. Again, you can take it or leave it, but that would be kind of what I would recommend to do. And here's how that would work. Let me make a little bit of white space over here on the side. Maybe a little bit up here too. Okay, so there's our shapes. Now, let's take a look at these. So what I have is a 1, 2, 3, 4. So I have a 4 by 4 square. So right now the area of the square is 4 times 4, which is 16. So what I'm going to do is I'm going to start pulling things out. See what I'm saying? This is the big shape. I want to take away the other stuff and leave me with the blue shaded region. Okay. So try to find things like triangles and rectangles or squares that'll make it really easy for you to be able to compute this. So I'm going to start with this shape right here. That is a rectangle that is 2 by 1. And so I'll jot that down up here. So I want to take away a 2, which is a 2 by 1 rectangle. Okay. Let's go next up to, where do I want to go? Probably over here. This is a triangle right here that is 2 on the top by 1 on the side. It's a right triangle. So 2 by 1, but that's going to give me, don't forget the formula is 1/2. Oops, pen's a little bit too thick there. It'd be 1/2 times 2 times 1. So half of 2 is 1 times 1 is 1. So I want to take away another 1. That takes care of those two pieces. I got a few more to do, so let's see if we can find another one maybe we can utilize here. What about coming down this side and up here? This is a triangle. It's a right triangle, so that's a quick one to calculate. And I'll just kind of color it here so we can kind of see it. There it is. And that is a 1, 2, 3 by 1. Okay, so now as I come up to write that down, it's 1/2 of 3 by 1. Oop, forgot to change the color. Let's see, your half of 3. So 3 times 1 is 3, times a half is minus 1/2. Okay, so we're getting there. We're getting there. Now let's take one more big chunk. And I'll use this bottom triangle at the bottom. I think that's a good one for me. I like that triangle at the bottom. And let's see here. Maybe I'll use, so see this one down here? This is a 4 by 2. So I'm just going to kind of color it a little bit there. 4 by 2. But it is a triangle, so I got to make sure I use the correct formula for the triangle then. So this is 1/2 times 4 times 2. Okay, so 4 times 2 is 8. I want half of that, so that's 4. Okay, so I've got almost everything done except for this one little triangle right here. And this one might be the most challenging of all. So I'm going to choose a different color to kind of really highlight it. So I want you to see the base is 1. The height, remember, would go from this point down to the side, which is 3. So this right here is a 1 by 3 rectangle. So I will go up and jot that down here. So it's a 1/2 times 3 times 1, and that's minus 1/2. All right, let's see if we can highlight a couple pieces here. 1/2 and 1/2, that's 3. let's see here, a 2 and a 1, that's 3, and then I still have a -4. I'm just trying to make it easier for myself. And 3 plus 3 is 6, plus 4 is 10. So basically, I want to take away 10 from this, and that leaves behind an area of 6. So the blue region in the middle is 6 square units. There we go. That's how we can do it. All right. So that's kind of the idea. Make shapes, build your triangles, see the shapes. You either add them up or you take them away. Now, if you wanted to, you could have gone through this entire problem and just said, why don't I build up? So, you would take this triangle and you would add that triangle. And then maybe you would find this big triangle next, right? And you would add this triangle to it. So that's 2 triangles. Then there's a bit of an issue because now if you look at what remains, right, we have kind of a weird shaped triangle, right? I mean, if we went this way, I guess we technically could do it, but it's just not easy. It's not a really nice one there. But I mean, you could because it would be the height of 2 or the base of 2 and the height of 1. And so we could find this one. But then again, you have this very strange triangle on the right-hand side. So again, I like the way that I did it, the initial way, because I think it creates less of kind of these concerns. But could you break this one up into other pieces? And the answer is yes. For example, you could break here, and this becomes a triangle with a base of 1 and a height of 1. And then you kind of bring that down to here. And this is a triangle with height of 1 and base of 1. So that's how you could get this weird piece and the other weird piece over there. Is it possible? Yes. Again, I just think it's not as consistent for students as they're doing it. So that was question 6. Let's see. Let me check the email. Question 8 is next. Okay. So it looks like probably part A, I'm going to say, is going to be okay. So again, that's just you have the base and the height. For part B, let me see if I can choose what's the lightest color I have on this. Does that show up okay? That shows up okay. For part B, I'd recommend draw the line from point B down to this side. And if you need to, then redraw triangle 1 and triangle 2. Separate them. Like even rotate them if you need to. Let me let me kind of show what I mean by that. Let me get a little white space going here. So once you do these little cuts, some people they'll twist the paper or they'll just kind of see it in their head. They can kind of turn and they say, okay, I see where the base and the height is. If you're struggling with that, just take a moment off to the side and say, okay, let me just bring this triangle number 1 out here. And I'm going to put the base of 8 right here. And that leads me over here to side A. And so I've just tipped it on its side. So this piece comes up like this, and then that comes back down. And they're telling me this piece right here is 6 centimeters. So actually now, yeah, maybe you can see it better. Here's the base, here's the height, and don't forget your area is 1/2 of your base times your height. Okay, so that's my tip. That's my hint. Rewrite it. If you don't like the way it looks, rewrite it. And a square and a triangle have one side in common. Where could the third vertex of the triangle lie? If the area of the triangle is equal exactly to the area of the square. So that might be one for GeoGebra. Again, I'm not sure. Let's see here. You can kind of clear everything off and make a GeoGebra for this, maybe. So we need to build a square. So I'd probably just do a regular polygon and say, here's a square. And then I want to build a triangle off of that, right? And so, I mean, you can think of just kind of building a random triangle and then measuring the area of those pieces together and just kind of see to kind of test it. I need the areas to be the same is what it said. So I need the area to be the same. So I need this piece needs to come up till it's about 14.44. Okay, so right about there it looks like. All right. So the reason I have you do that is when you start thinking about where is that distance, you can actually measure now and say, okay, well, what do I know about this side length of the square? And the side length is length 3.80005. Okay, and that's true for all of those. Now, create the height of your triangle by doing a perpendicular line and then creating a point. Then measure the distance between those 2 points, and you can see, hey, wait a minute, that length looks, those look pretty similar. And if you needed to, you can go over to the calculator port over here and say, wait a minute, what is that length? So E is segment CD. So that's E. And then distance FE is right here. So if I do distance FE divide by E, you'll notice I get a number that's very, very, very close to 2. And that might be enough of a hint for you to say, wait a minute, if I want the areas to be pretty darn close, 14.4, 14.4, look at that ratio. The ratio stays right around 2, and that might help you come to kind of a why is that the case? All right, can you justify why the height of the triangle has to be twice as long? And that is my hint. So hopefully that gets you going on the right track. If not, please let me know. I'll respond with another question. I'll get you a video. I can meet up with you in person, or we can talk about it in class. All right, have a great rest of your day. Off you go.